Welcome to a brief introduction to the classification of characteristics, critical to quality process. What is a classification of characteristics? It is the process of classifying the drawing characteristics, identifying and prioritizing the 20%, vital few, of the characteristics that account for approximately 80% of the component function. Advantages of a classification of characteristics: align departmental priorities, work smarter not harder by applying 80% of resources on critical characteristics, focus statistical process controls on critical characteristics, focus PFMEAs on the processes that manufacture the critical characteristics. Classification categories: minor characteristic, an attribute that does not impact the mission negatively; major characteristic, an attribute that if fails, could cause mission failure; critical characteristic, an attribute that if fails, could cause serious mission failure, injury and/or damage. Step 1. Form a team. This typically includes these departments: 1. Quality, 2. Process engineering, 3. Design, 4. Production, or any other relevant department. Step 2. Identify functions. Any verb can be combined with any noun to describe the functions of the item. See examples in the image on the left. Step 3. Transfer the functions. The identified functions are transferred to the paired analysis sheet, which is a comparative scaling technique wherein a team is comparing two functions at the same time and is asked to select one according to the defined criteria. The paired analysis is used to unbiasedly prioritize and set weights for the functions. Step 4. Prioritize and weigh functions. The functions are prioritized and weighted as a group using the paired analysis method. As shown in the following slides. How the paired analysis works. First, each function is listed in the left column of the paired analysis sheet. Then each function is then compared to every other function in pairs. For example, compare function A to function B, and then compare function A to function C, then function A to function D, and so on, until function A has been compared to every other function in turn, then compare B to all other functions, then compare C, etc. See example on the next slide. When, for example, comparing functions A against B, the question is asked, is A much more important than B? If it is it much more important, slightly more important, or marginally more important? If a function is deemed much more important, it is given a score of 3. If deemed more important, then the score of 2 is given, and if deemed only marginally more important, then the score of 1 is given. However, if, for example, function B is more important than A, then these weights are given to function B instead. Only when every function has been compared against every other function are the weights summed up to provide a resulting score, which can then be multiplied by a factor to make the weights more sensitive. In this example, a factor of 5 was used. Step 5. Prioritize functions using a paired analysis. Here is an example of the paired analysis. Note how function A is compared to function B, then function C, and D, continuing through to function N. Also note the scores and weights. Step 6. Compile a table of functions and their related weights like this one. Step 6. Transfer functions to the CTQ worksheet. The functions and corresponding weights are transferred onto a CTQ worksheet across the top row of the sheet for later use in the analysis process. As seen on the next slide. Here we can see the functions and their weights across the top row. Step 8. Prepare the drawing characteristics. Take the component drawing and number each characteristic with a unique number. Transfer these characteristics onto the CTQ spreadsheet in the first column. You should now have the functions and their weights across the top of the sheet, and the characteristics down the left-hand column. Step 9. Transfer the drawing characteristics. Transfer the drawing characteristics into the left characteristics column of the CTQ spreadsheet as seen in the following simple example. In this example, we can see an example of the functions across the top row and the characteristics down the first column. With the functions and characteristics transferred to the CTQ worksheet, the team answers the following question. If the characteristic exceeds its tolerance by 50%, what function is affected? The characteristic funct inherits the function weight. These weights, which are summed up to enable a Pareto chart to be drawn up to identify the 20% critical to quality characteristics. Step 10. Prepare a Pareto diagram. Prepare a Pareto diagram highlighting the 20% of characteristics affecting 80% of the function. These characteristics are considered for sampling size calculations, SPC, verification and validation, capability and MSA requirements, which are documented in the control plan for both in-house production and suppliers. Step 11. Develop a control plan. These CTQ, 20% of characteristics, are assessed for sampling size calculations, SPC to be applied, verification and validation, capability studies and MSA requirements, all of which are to be documented in a control plan for both in-house production and suppliers. Thank you for your attention.